Hello. In this video, we're going to cover some quote-unquote tricks in arithmetic and base conversion. Starting off with one of the quote-unquote tricks, which is called the complement of nines. To do the complement of nines, you want to first align the digits of which you're subtracting, as you see have been done in each of the examples. The next thing you're going to want to do is insert leading zeros. Leading means a zero in front, and just where necessary. So I'll have the 543, and I'll put minus 085. The next thing that says is replace the amount being subtracted with its nines complement. A nines complement means how much do you have to add to that number to get 9? Or 9 minus that number is what? The top number you're going to always keep as it is. But now, left to right, let me find the nines complement of each digit. So the nines complement of 0. 0 plus what gives you 9? Well, 9 itself. Then 8. 8 plus what gives you 9? That'd be 1. And 5 plus what gives you 9? That would be 4. And now it becomes addition. The next step says just add normally. And when you add, you're always going to end up with this 1 in front. That's called a leading one, and what you're going to do with this one is you're going to add it to the ones place, which will give you 458. Now that is actually the answer of 543 minus 85. This is a neat little trick to do subtraction. Now let me try it again. The top number always stays as it is. So I have 30,457. And the number which is being subtracted, insert any leading zeros if necessary. So I need 1 leading 0. And now I'm going to change this from subtraction to addition. Still have 30,457. But now find the nines complement for each digit from what was being subtracted. So the nines complement of 0 is 9. For 5 it is 4. For 8 it is 1. For 9 plus what gives you 9? 0. And 6 plus what gives you 9? That would be 3. Then I will add these. So I ended up adding 30,457 and 94,103, which gives you 124,560. And the last step says take that leading one and add it to the ones place, which would give you 24,561. And again, this is a neat little trick if you don't like subtracting, but you can add. Now the next quote-unquote trick I have here is what's called lattice multiplication. To do lattice multiplication, you're first going to create a lattice with one number on the top, one number on the side. It does not matter the order of these two, but usually you'll see the larger number on the top. And then you're going to have to draw these diagonals for each of the boxes. Now it says, do the multiplication of each corresponding row and column number. Now the numbers I'm multiplying are 38 and 794. As I just mentioned, it usually looks better to have the larger number on top, so I put 794 on top and 38 downwards on the side. Now I'm going to need to do the multiplication of each corresponding row and column. It does not matter where you would start, you'll have to end up multiplying everything. Now I'll start off with 4 and 3. Well, 4 times 3 will give me 12. So I'll put a 1 in that part of the box and a 2 in that part of the box. Now I'll do 4 times 8. That's 32. So I'll put a 3 there. And I'll put a 2 down here. Next I have 9 and 3. 9 times 3 is 27. So I'll put a 2 there and a 7 there. Next I have 9 times 8. 9 times 8 is 72. So a 7 here, a 2 here. 7 times 3 is 21, so a 2 here, 1 here. And lastly, I have 7 times 8, which is 56. So a 5 here, 6 here. Now it says I am to add diagonally and downwards, starting with the farthest right, working my way left. Now what that means is I'm going to start off with the farthest bottom right I have, which is just 2. Well, that's just going to give me the number 2. I have nothing to add it with. Then I take the next diagonal, which is 2, 3, and 2, add those. That's going to give me 7. Then I do the next diagonal. And when you're adding these, you ignore the numbers that are outside the box. So in the next diagonal, I have 1, 7, 7, and 6. When I add 1, 7, 7, and 6, that's actually going to give me 21. Well, I need a single digit here. I'll put the 1 here, but I'm going to have to carry the 2 to the next column. And now I will add this diagonal, which is the 2 which I carried, 2, 1, and 5. Well, 2 plus 2 plus 1 plus 5 gives you 10, so same idea. I'll put the 0 here, but I'll have to carry the 1 to the next diagonal. And then my top left is just 1 and 2. Add those, and that will just give me 3. Now let me just clean this up. 38 times 794 will give me 30,172. And this is lattice multiplication. So I have another example here, which is 912 times 483. You do usually put the larger number on top, but it's also the number that has the most place values is good to put on top. But again, it does not matter, and especially in this case, no matter how I would put the numbers for what's on top or what's on side, I'll still have a box that ends up looking like this. Now I have to go through and do all of the multiplication. I'll start in the top right, which is 2 and 4. 2 times 4 is 8, which means I'm going to put a 0 in this part of the box and an 8 in this part of the box. Because each of these boxes represents 2 digits. I'll go straight down. 2 times 8 would be 16. And then below that, 2 times 3 will be 6, so 0, 6. Now I'll work the next column, top to bottom. First, 1 times 4 will give me 4, so 0, 4. Next will be 1 times 8, which will be 0, 8. And then lastly, I have 1 times 3, so that will just be 0, 3. Now the first column is 9 times. So 9 times 4 will be 36. 9 times 8 is going to give me 72. And 9 times 3 will give me 27. Now I start in the very bottom right and start adding diagonals. The bottom right is just 6. The next diagonal is 6 plus 0 plus 3. That will give me 9. In the next diagonal, I have 8 plus 1 plus 8 plus 0 plus 7. When I add up all of those, that is actually going to give me 23. So I'll put a 3 at the bottom, but I will need to carry the 2 into the next diagonal. Now I have the 2 which I carried, plus 0, plus 4, plus 0, plus 2, plus 2. And that's going to give me 10, so I'll put a 0 here, and I will have to carry the 1 to the next diagonal. In the next diagonal, I have the 1 which I just carried, plus 0, plus 6, plus 7. And when I add up those, that will give me 14, so I will put a 4, and then I'll have to carry the 1. And now I just have 1 plus 3, which will just give me 4. So 912 times 483 is going to give me 440,396. And this is lattice multiplication. Now this is sort of similar to the Egyptian algorithm from the previous video. This is multiplying using what's called the Russian peasant method. To do the Russian peasant method, you first want to write down both numbers, which I've already done for each example. Step 2 here says take the left-hand side number, in this case 45, and divide it by 2, ignoring remainders. Now, remember, when you are multiplying, it does not matter if you have something like 1 times 3 or 3 times 1, or in this case, I can do 45 times 31 or 31 times 45. A hint here is, when doing the Russian peasant method, have the bigger number on the left side, because the step 2 says take the left-hand side number and divide it by 2. That means you're going to be taking the bigger number, making it smaller, and that's going to be better than taking the smaller number and just making it smaller, because then that would turn to number 3, or step 3 says take the right-hand side number and double it. So if you're given an example here where the number on the left is bigger than the number on the right, that's okay. But if it's something like the second example here, 63 times 145, yeah, I'm going to end up swapping the location of those two numbers. So sorry for that sidetrack. So step 1, write down both numbers. I did it. Number 2 says take the left-hand side number and divide it by 2, but ignoring remainders. So I take 45 divided by 2. How many times does 2 go into 45 by division? That'd be 22. Again, ignore the remainder. Then I take 22 divided by 2. It's 11. Take 11 divided by 2. So how many times does 2 go into 11? That'd be 5. How many times does 2 go into 5? That'd be twice. And how many times does 2 go into 2? That's 1. And it says for step 4, stop when you get 1 on the left-hand side. I got 1 on the left-hand side, so I stop. Now on the right, for the number 31, I will need to start doubling that number. So doubling means also multiply by 2. And if you want on your calculator, you can start with 31 times 2, which gives you 62. And then on your calculator, you should be able to just push times 2 again. And that should give you 124. And on your calculator, you should be able to push just times 2 again, which gives you 248. Times 2 again, 496. And times 2 again is 992. Just continuously pushing the times 2 is easier than having to retype the number all over again. Now step 5 says identify the odd numbers on the left-hand side. Any and all odd numbers, that is. So I have an odd number being 45, 11, 5, and 1. The number at the bottom, you should always get 1, and that's always going to be one of these. And then number 6 says add those corresponding numbers from the right-hand side. So I am going to be adding 31, 124, 248, and 992. And you can use your calculator to just add these 4 numbers. And you should end up with 1,395. Now if you check 45 times 31, that is the same answer. Now over here on the second example, I have 63 times 145. And as I said just not long ago, I can leave it like it is, that's fine. Or I could switch the location of these 2 numbers. And I will do that. Now I will take the left-hand side and divide it by 2, ignoring remainders. So I have to take 145 divided by 2. And if you punch that in on a calculator, 145 divided by 2, you're going to get 72 point something. What that means is 145 divided by 2 will give you 72, and the decimal part is essentially a remainder, and as it states in the directions, for this process you ignore the remainder. Now 72 divided by 2 will give you 36. 36 divided by 2 will be 18. 18 divided by 2 will give you 9. 9 divided by 2 will give you 4. 4 divided by 2 is 2, and 2 divided by 2 is 1. Now I go back up to 63, and I have to start doubling, which means multiply by 2. So on your calculators, punch in 63 times 2 equals 126. And then immediately just push times 2 again, and you get 252 times 2, 504, times 2 is 1008, times 2 will be 2016, times 2 will be 4032, and times 2 is 8064. Now I need to identify the odd numbers on the left-hand side. One is an odd, 9, and 145. And now I'll need to add those corresponding numbers from the right side. And it does not matter if you start from the top to the bottom or the bottom to the top. So I have one of the corresponding numbers to an odd is 8064. Another one is 1008. And my last one is 63. And I will need to add those. So on a calculator, punch in 8064 plus 1008 plus 63, and you're going to get 9,135. And this is multiplying using the Russian peasant method. Now we're going to get into what's called base conversion. A base is a counting system. Now you encountered a couple of these in the previous lesson, where you had Babylonians and Mayans counted or had place values differently than what you're accustomed. What you're accustomed to would be the base 10 system, or called the decimal system. For that, we count 0 to 9, and then we actually go to the next place value once we go past 9. And then that place value we count 0 to 9, and then once we hit beyond 9, we go to the following place value. Now for a base 10 system, which is at the very bottom here, I have the first farthest right, which is the ones place. Anything raised to a 0 power is always going to give you 1. And then after that, I have 10 to the first power. 10 to the first power will give you 10, which is why they call it the tens place. And after that, you have the hundreds place, because that is 10 to the second power. And after that is 10 to the third, which is the thousands place. But this is the reasoning of why each of these place values is called what it is. Now in other bases, like for base 5, you would count 0 to 4, then go to the next place value. So you'd go 0, 1, 2, 3, 4, but you will not hit 5 because it's a base 5. Just think about it as we actually don't have a single value or we don't have a single number for 10, rather that's a combination of two digits. So for base 5, you would count 0, 1, 2, 3, 4, then go to the next place value and start counting again. It already has 0, so 1, 2, 3, 4, then go to the next place value. Now for something like base 3, 3 to the 0 power is still 1. 3 to the first would be 3. And what this represents is base 3 has a 1's place, then actually a 3's place. And then after that, 3 squared is 9, so it has then a 9's place, a 27's place, and then you're going to have an 81st place. And it'll keep going on and on. For base 6, on the far right, it does have a 1's place. In fact, all of these always have a 1's place to begin. Then for base 6, a 6 to the first power will give you 6. Then 6 squared is 36, and it continues onwards from there. Now I did put a note, and that note is right here. Numbers written in bases, besides 10, they must be read by each digit. So when you see this 145, that's exactly how it's read. It's read 14 base 5. So that little subscript number is your base. Now if you look at other videos, sometimes they might write the literal word. That's fine. If you want to use the digit for the base, I'm okay with that as well. But when you see 14 in base 5, it must be read like that. You cannot say 14 base 5, because 14 represents a decimal or base 10 number. And for base 5, no digits can exceed the number 4 itself. So now let's get some examples on converting with bases. So to convert to a base 10 system, which is called also the decimal number or decimal system, you want to take each digit from the right to the left and multiply by that corresponding base raised to that corresponding power, then add the results. So I gave an example of 1342 in base 5. So I started with the farthest right number, which was 2, and I multiplied that by 5 to the 0 power. And then plus the next to the left digit, which was 4, times 5 to the first, plus the next, which was 3 times 5 squared, and then plus 1 times 5 cubed. And I just punched those in, those groups, one at a time to a calculator. 5 to the 0 power, or anything to the 0 power, is always going to become 1. So in this first group I have 2 times 1. Anything to the first power is just the base itself. So I have 4 times 5, which is 20. And then I have 3 times 5 squared. For the smaller bases, if you wanted to just do that in your head, that's okay. So 5 squared is 25. 25 times 3 is 75. And then 1 times 5 cubed would give you 125. Now that I have all those 4 numbers written down, I just add them, and I end up with 222. And I can read it as 100 because that is a base 10 number. Now I want to convert 1203 1201 in base 3 to a decimal number. So I'll start off with the farthest right number or digit, which is a 1, and that will be times 3 to the 0 power. And then the next to the left digit, which is 0, will be times 3 to the first. And the next digit is a 2, which will be times 3 to the second. And then the next, which is a 1, and that'll be times 3 to the third power. So figure out which each group gives you. The first group, anything to the 0 power is 1, so I technically have 1 times 1 is 1. 0 times anything is always 0. The next group, I have 2 times 3 squared. 3 squared is 9. 2 times 9 will give me 18. And then I have 1 times 3 cubed. That's going to give me 27. And I will now need to add these 4 numbers. When I add these 4 numbers, that will give me 46. That means 1201 in base 3 is the same thing as what you're used to, the number 46. Now I'll convert 650 in base 7 to a decimal number. So I'll start off with the farthest right number, which is 0. And that'll be multiplied by the base raised to the 0 power. Next number is 5. That'll be times 7 to 1 higher power, which is 1. And then the next digit, which is 6, will be then times 7 to the second power. Do each multiplication for each group. 0 times something is always 0. This is 5 times 7, which is 35. And 6 times 7 squared will give me 294. Add these numbers up, and this is going to give me 329. So 650 in base 7 is 329. I have seen some videos and other ways of converting a base number to a decimal number, and that's fine as well. I just went with this method because it's easy to see that you have like in this case 3 to the 0 power, 3 to the first, 3 to the second, 3 to the third. But if you do another method, I do understand that there are some. Now I want to go the other direction, which is converting a base 10 number to a different base. And to do this, you can perform what I've heard called upside down division, which is still a division with remainder. So it says divide the decimal number by the base number. So I'm going to take 7 into 7508. And this is where it gets the name upside down division. where you have that division or long division bar upside down. Now, to the right of this 7508, I'll write remainder, because I'm going to have a list of the remainders. So pull out your calculator and do 7508 divided by 7. You should get 1072 point something. 1072 goes here. Now, to calculate the remainder, you're going to take 7508 and subtract 1072 times 7. And that should give you 4. And I'm going to continue doing this division until I end up with a 0, meaning I can't divide anymore. So now take 1072 divided by 7. And you should get 153. Now, to get the remainder, I will take 1072 minus 153 times 7. That should give you 1. Come back to the division. Do 7 into 153. 7 goes into 153 21 times. Come off to the side. Take your previous answer, which was 153, and subtract 21 times 7. And that should give you 6. Go back to the long division. 7 goes into 21 3 times. And that does have a remainder of 0, because you would do 21 minus 3 times 7. Divide by 7 again. How many times does 7 go into 3? 0. So what's the remainder of 7 going into 3? That's 3 itself. And you can get this number by one of two things, or two ways. First way, whatever would be right above 0 will end up going there. The second way, if you keep following the process that it's been going on, you take 3, the previous answer, minus 0 times 7, that will still give you 3. Now, the last step up on top says write the remainders from the bottom up. So my remainders are 3, 0, 6, 1, 4. Bottom up. And write the base number in the appropriate location. So this is base 7, so I have a subscript 7. So 7,508 in base 7 is 30614 in base 7. This does require you to be very neat and organized with what you're writing and where. Please try and keep it organized so that way it's easy for me to follow when you're doing your work on your own. Now again, I want to convert the number 1,305, and I know that's a decimal because I don't see any number in the base location. If you do not see anything in the bottom right corner as a subscript, it's considered to be a base 10 number, or also called a decimal number. Now, since I'm converting to base 5, I'm going to do 5 into that number. So start off with 5 going into 1305. And beside that, I'll have remainders. So in your calculators, punch in 1305 divided by 5, and you get exactly 261, which means a remainder of 0. And if you wanted to follow with what I was doing before, the way to get that is you take what was above, which was 1305, minus 261 times 5. Divide by 5 again. 261 divided by 5 is going to give you 52 something. So you can do 261, previous answer, minus 52 times 5. And that's going to give you 1. Come back to the left. 52 divided by 5 is going to give you 10. Go to the remainders. 52 minus 10 times 5 will give you 2. Go to the division. How many times does 5 go into 10? That's twice. And it does have 0 remainder because there's no decimal. And if you want to check yourself, that would be 10 minus 2 times 5. That's correct. How many times does 5 go into 2? 0 times. So I can write down the number right above 0, which was 2. And that's also found by taking 2 minus 0 times 5. Now read the remainders from the bottom up, which would be 2, 0, 2, 1, 0, and that's in base 5. Now I want to convert a base to another base. To convert one base to a second base, this is a conjunction of the two previous examples. I'm first going to have to convert my starting base to a decimal number. And remember, that was done by doing some multiplication. And then I'll take that answer and convert it to the final base, in this case base 5, and that's by doing the upside down division with remainder. So I need to start off with 3164 in base 7 and make that a decimal number. To make that into a decimal number, I take the farthest right digit, which is 4, times the base to the 0 power. Move to the next digit, which is 6. That'll be times 7 to the first. Then I take the next digit, which is 1. That'll be times 7 to the second. And the next digit, which is 3, and that'll be times 7 to the third. Punch each of these in, or if you want, you can punch straight from the left all the way to the right, and you should end up with 1, 1, 2, 4. But since this is a decimal or base 10 number, it's actually 1,124. So now what I want to do is I want to do 1,124 and make that a base 5 number. To make it into a base 5 number, do upside down division. So 5 is going to go into 1124, and to the right of that, write remainder. So punch in your calculators 1124 divided by 5. And you should end up with 224. Now to find the remainder, I will do my number above, 1124, minus 224 times 5. And that's going to give me 4. Go back to the long division. 5 into 224. That'll be 44. And to find my remainder, I will take 224 minus 44 times 5. And that will give me 4 again. Now I'll do 5 into 44. So how many times does 5 go into 44? That's 8. For my remainder, I have 44 minus 8 times 5, which will be 4. How many times does 5 go into 8? That's 1 time. And you might know that's a remainder of 3, but if you want to double check, you would do 8 minus 1 times 5, which does give you 3. And once more, 5 goes into 1 no times. Your remainder would be 1, which you can double check by doing what is the number above 1 minus 0 times 5. Read the remainders from bottom up, and you end up with 1, 3, 4, 4, 4, and that would be in base 5. Thank you for watching the video. If you have any questions, remember, always feel free to email me, ask me questions, and I will get back with you. Thank you, and I'll see you in the next video.